Okay, so continuing on with the whole safety related stuff, jumping back into the hardware real quick, I want to go over a few pieces of safety with this. If we go into the CPU itself and then into the F parameters, there's a few parameters in here that should be thought of. The first is the safety mode can be deactivated, which is actually also under the protection tab. I usually leave that on. The base for ProfiSafe addresses. What this is that in the safety related stuff, there's two addresses that are kind of important. The first is like the PLC, like the F source as it's called. This is the F source for the PLC. Its F source address is going to be 2000, and each device is going to have an F destination number, and those will be unique per each device, and we'll see that as we go on. But this is where you set the PLC's F address. From here, it's just defining a from and up to block numbers to use for F data blocks and F function blocks if they're automatically generated. This is the area we want to put them in. We can go into the protection tab. This is that same one. F mode can be, or safety mode can be deactivated. We want to be able to access protect the F CPU, but can be bypassed with a password. We enter that password in here, and then we say the CPU contains a safety program. And that's it for the PLC side of the safety. So if we go to the F switch, which in my case is the only safety device I have on here, it's part of the main rack. The F switch, which the F switch will stop output power to cards after it. So I can have a, say, an output card here, like this one back over here that says it doesn't allow power out of that guy unless the F switch is happy. So in the F switch, we have just like the basic address of what you're going to be using there. Identification is irrelevant. The parameters are the important bit. So in the F parameters, the first thing we're going to see is the F source address. This is 2000, the PLC's address that we just looked at. The F destination address is the address specific to this card. Now, physically on this card, there are dip switches, and those dip switches have to be set as 200. And it's really nice that they give you the dip switch setting here. Of course, if you went into, like, say, calculator and chose programmer and put 200 in decimal, you would see in binary you get the same numbers here, but this has the 10-ish bits for the dip switches that you'll see on the device itself. Now, I got kind of lucky when I set up my original hardware that the default address of 200, what the card was already set to when I put it in there. And then you have the F monitoring time. So this is going to be sending a packet back and forth to the PLC, and if it doesn't respond within 150 milliseconds, then the PLC is like, oh, something's wrong, stop everything. So then we go on to some more stuff about safety. So behavior after the channel faults. If something were to fault in the channel, do we want to fault the entire module, or do we want to just passivate just that one channel that faulted? Because in this case, we have on this F safety card, we have two inputs, and we have the one output that just allows power to pass through. So the short circuit test, this is kind of cryptic, but what it does is cyclic is default, and if you have just like a e-stop button where it's just two channels of wires coming out of the card and back into the card, cyclic is fine. It's a short circuit test. That's all good and stuff. If you have a light curtain that has its own power that is simply only sending two channels of 24 volts back to the PLC, then you're going to want to set this to lock so that it's not trying to do a short circuit test coming out of the F card and back into the F card, because it doesn't work like that. You're sick because you're just sending 24 volts to a light curtain or a similar device did that, just sending it straight 24 volts back to the card. So that would be important to know when you're setting this up. So go into the individual inputs themselves. We have for each channel, and when I say channel, I'm talking about a pairing of channels, because safety is always in pairs. And a lot of cards, a lot of safety cards, you'll see 1 to 2 or 1 to 1 evaluation. And 1 to 1, if you choose that, the rest of the stuff goes gray because it's irrelevant. You're looking at individual inputs, like 0 and 2 or 0 and 4, or something like that. Whatever pairs it is depends on the card you have. In this case, we are looking at here's another internal or external power supply. If you're using internal, that's the same kind of short circuit cyclical test that it's going to be looking back for. External means like you're using 24 volts supplied by something else, like the light curtain. 1 to 2, because this is because this is an F switch, we don't have a 1-to-1 evaluation. This is always just going to be 1 to 2. And so we're looking for a 2-channel equivalent. The rest of the stuff, I never use it. It's always 2-channel equivalent. This does get changed. I always change this to supply a 0 value, not just the last value known. Because if something goes wrong, we want to kill the system. Therefore, it should say 0. No good. Do not go. Discrepancy time. Discrepancy time between the 2 channels. In this case, channel 0 or inputs 0 and 2. How much time should pass before you throw a discrepancy fault? Discrepancy fault means 1 turned on, but 2 didn't turn on in this time period. If you have 2 turning on, but not 1, then that would be in the same. This is the timer you're looking at. Regularly, 50 milliseconds is what I put for an e-stop, and reintegration after discrepancy error. What this means is that I want to see both channel goes low before I say this error can be cleared and we're good to go again. So for my other one, I don't have anything plugged into it, so I'm just going to say turn that all off, and it grades it all out, and we can hit OK. Now this, when we hit OK, it's going to say you've changed the safety thing, and we're going to say yeah, fine, close. I'm not going to hit save because that just saves that fault. Who cares? So now we're going to hit OK again, and the fault doesn't pop up again. So now we're going to go ahead and hit save and compile. We're going to hit download to the PLC. Yes, we're downloading to this PLC. Okay, so once we've gotten here into our select node address, or where we download into, we've already downloaded to this address before, so we know this is the address we want. We're just going to hit OK, and we're going to say stop the module. Yeah, stop the module. Go ahead. All right, now that we've stopped the module and downloaded, do you want to start the module? Yes, we want to start the module. So there we go. Now the PLC is going to take a moment to go back into run mode. You can go ahead and hit go online to see. All right, it already got there. Perfect. Nothing's red. For instance, if the F switch were to have a different dip switch setting on it, it would have a little red circle with an X through it on here. We could go to the module information, and it would have something like under the diagnostic buffer, it would say something along the lines of CRC, redundancy check error, or that usually tells me that either we haven't downloaded the safety appropriately yet, or that my dip switches are set wrong. In this case, it's saying I have a discrepancy error on my channel, so we'll look at that later. So go ahead and turn this offline. Oh yeah, by the way, what it does is just creates two windows. One is an offline, one's an online. So we'll go ahead and just close the online. All right, so going back into the program, here's where it gets a little complicated. From our hardware, we have our PLC, and our PLC, we have our blocks. This is our program. What it creates by default is a few things that are always going to be there for safety, and then it creates one database per type of hardware module that references safety. So now before we go up to here and create our safety program, we actually have to create our safety program. So we're going to right click, enter new object, and we're going to say function block. And I'm just going to call this function block 500. This is going to be our FB safety. Cool. And it's going to be an F ladder, okay? So F ladder is what we're going to choose for this. F ladder, all right? Now we're going to right click again. We're going to say function. And this is what we're going to call our function call. Function call is going to be different. That's going to be at the bottom of this guy. Let's call him our FC call. Do it all caps because why not? All right, so we're going to go up create our safety program. Click this. We're going to go to F runtime groups. We're going to see there's no program in here. We're going to hit new. We're going to use that F call block, FC500. It already knows which one I'm talking about. Our F program block, FB, it's already there. All right, and here we're going to hit DB500. The max cycle time of the F runtime is 200 milliseconds. So if something goes beyond 200 milliseconds, we're going to fault the safety stuff, and it's all going to stop. So we're going to hit OK. And cool. So we got our F runtime with all this good stuff in there. We're going to hit OK. Notice DB500 is not yet created, so it says, I don't know what this is, but OK. You are missing the blocks, specifically probably that DB. We're going to hit yes. We want to create that guy. So up there it is, DB500. And then we're going to hit compile. Good, there it is. Successfully generated. This is just saying it's not used. It's kind of irrelevant right now. We're going to hit close. We're going to hit download. Before I hit download, though, I want you to see this bracketry here. Right now, there is something running on the PLC that is activated. However, something has changed, so therefore it puts brackets around this. You might also see CPU and stop with brackets. You might see deactivated. But what we're going to do is continue downloading here. You want to include the standard blocks located in the folder. Normally, I'd say don't do this. You hit no because that's going to download everything to the PLC. But in this case, we are going to download everything to the PLC because it's the first runtime through. So we're going to hit yes. Just stop the block or stop the PLC. We're going to hit yes to that. Ask for a password. Going to go ahead and give it the password. Hit OK. Going to download the safety program. You want to start the PLC now? Yeah, let's do it. Now we have activated with no brackets, so it is running and happy. So we go ahead and hit close on this one. So that created a few more blocks by itself. Now here's something I wanted to warn you about. If you ever get a function block during the compile that errors out, and then you go to your program and you don't see that block exist anywhere, say like FB277 failed to compile, but you look and there is no FB277. Be like, what? Yeah, what you have to do is close your program, turn off your computer, and turn your computer back on. I've wasted an entire day trying to figure out what went wrong, and my boss is like, hey, did you restart your computer? I'm like, no. So I restarted my computer, issue is gone. And that has been the solution ever since. So continuing on, let's go ahead and look at our safety stuff now. So what I want to do is I want to go back into my hardware config, and I want to look at the F switch. I have an e-stop plugged into it right now. I can come down here to monitor and modify. I can see the inputs and the outputs of my PLC. So I can go hit monitor, and they are all off right now. Now my e-stop is not pushed. If I push my e-stop, still nothing happens. If I unclick my e-stop, still nothing happens. Okay, going back over the wiring was just fine. I eventually figured out what the problem is, and I'm glad I'm making these videos because I will forget this later again. So anyways, my e-stop is unpressed, but I don't have my input here. So I looked at the wiring. The wiring was good. The two channels were there. The e-stop itself rang out properly. I am using a 5-pin wire, and by the way, 5-pin cable has got me before where we have a whole lot of 4-pin around, but the 5 pins are more rare. But this because it uses the 5th pin as a safety channel input, needs to be there, and so I've gotten caught with that before, but this has that. So then why isn't my e-stop showing up as good here when it's unpressed? Well, let me show you why. Each of these databases that's made for each safety address needs to be reintegrated into the safety before it can be used. So to do that, what we're going to do is go ahead and open up our FB safety here. Now it's going to give us a blank program. So to integrate our safety device, first thing we want to do is we're going to enable the reintegration. And that, if we click here, we go ahead and hit F. And we see our F switch database here. We're going to open that up. And we're going to say the ACK is necessary. So this is the bit that should be on all the time. Now, in some cases, you may use M0.1 as your always on bit. In this case, I haven't even set that up myself yet. So it has a red box over it. The red box means this is a not safety tag to be using. It's not going to fault your program. It's not going to not work. It's just going to tell you this isn't safety. So maybe you think of something else. Now, luckily for us, there is another type of bit we can use. It's always on, and then it's actually hidden in the F global DB. Now, hidden by mean if I click this to expand it, it's not going to open it. However, we can click this and we can, at the end, VKE1. And that's the hidden always on for safety. There's also a VKE0, which is going to be your hidden always off. But you can use that as hidden as the always on, always off for your safety program. So that's going to tell us that we need to acknowledge this guy. And then this, we're going to use a bit, I'll just say M10.0, even though it's not safety. I'm just using it to set the card for acknowledgement. We're going to hit a coil. We're going to go back to our F switch here, and we're going to say reintegrate. That's the REI. So cool, just like that. We're going to go ahead and want to save this. Okay. Go ahead and close this guy. I find this silly. I just saved it. You want to save it? Yeah, I want to save it. I just saved it. Anyways, going back up to here, we got to recompile and re-download our safety all over again. See how it says activate the brackets there. We're going to hit compile. All successfully generated. Close. We're going to download. Do you want to download everything? No, just the safety. Download it and stop the module? Yes. So it's going to go ahead and download just the safety. Start the module? Yes. Okay, cool. All right, so we can go into the FB here. We can go into view. You can see the act necessary is true. And so what I'm going to do is just right click this guy, flip to true, flip to false. And you can normally tie this to like a safety reset, like HMI push button, like a power on push button, physical push button on your machine to do so. So now if we go back into our hardware and go to F switch, we can right click this guy, go down to monitor modify, and then hit monitor. We can see there it is finally. And so if I push this button, click off, and if I reset it, there it is, it's true. Awesome stuff. So now I can use that in my safety program as an input. So I would just go, in this case, I0.0. I can stop viewing this. And then later down here, I can say like, if I 0.0, which is my input, I didn't label it, sorry. And I can go to, let's see, for the 3 channels of the F safety, Q00, 01, and 02. Q00, and I can create a drop down of the rest of these. Have that created. I'm going to go ahead and hit save. Okay. Close. Oh, it didn't ask me a second time. Okay. Oh, yeah, by the way, when you're downloading, do not have any active monitoring things running. So we're going to close this guy. Because if you try to download while things are monitoring, it does not go well. I go back to my blocks, click up here in my safety thing, activate it with changes. So we're going to go ahead and compile. Our good, successfully generated. We're going to hit download. Do you want to include everything? No. Want to stop? Yes. Downloads. You want to start? Yes. Okay, cool. So if I go over to my stuff here, the program should be running. So if this is on, then all the outputs should be on. So I can go ahead and click this off. All my outputs turn off. Click it back in. Everything turns back on. So now I have power flowing through the F switch to my device, or my devices after that. And there you go. That's the basics of getting safety set up. Okay, bye.